cuts it in half. If something has been bisected, it's been cut in half. And what are we cutting in half here? We're cutting the angles in half. And we're extending that segment to the other side. Let's look at this first one here on the left. Okay, that's our notation for angles that are the same. Let's give it a physical measurement. I don't know that that's exactly 10 degrees, but I'm going to say that it's 10 degrees. So they're both there. Okay, let's look at this other one. These are the same. I'm a little bit bigger. Let's say these are 50 degrees. So right now I've used up 120 degrees in my triangle. I've got 60 degrees left, so that means that these are both 30 degrees. Okay, those angles have been cut in half. And when the three angle bisectors meet, they meet at a point called the incenter. They meet at a point called the incenter. Now, here is the special property of the incenter. The incenter is what we call in the geometry world equidistant. That's just a fancy way of saying that it's the same distance. Break down the word. If you don't know what it means, break it down. Equa sounds like equal, right? Distant, distance, same distance from the sides of the triangle. It's equidistant, same distance from the sides of the triangle. So what you do is you measure the closest distance. So it's actually going to form a right angle with the side. So you need to draw those little segments in there. You go from the center to the side, closest distance that you possibly can. And my picture's pretty decent here. They look pretty close to the same length. Those three segments do. And just for clarity's sake, let's give them a length. Let's say they're length 3. Okay, all of those are length 3. I like to label it with both a number and with the geometric notation, just in case you forget what those little tick marks mean. They mean that they're all the same. So the next 3 words in our sentence are bringing in. All of my children are bringing in. So the A stands for angle, bisector, and the I stands for incenter. All of my children are bringing in. Altitudes, orthocenter. Medians, centroid. Angle bisectors, incenter. Okay. Let's look at the incenter. See if we can do anything different with it. If I move it around, it is always going to be inside of my triangle. Okay, those angle bisectors are always inside the triangle, so the incenter is always inside the triangle. Notice here there's a picture, or there's a circle inside of our triangle. That is an inscribed circle. That means it's inside of the figure. And notice what it does. It extends to all the sides of the triangle, and it actually touches the triangle where the angle bisectors, well, no, it didn't. That was just a special case right there. But it fits right inside of the triangle, and the center of the circle is the incenter of the triangle. So it's an inscribed circle, a circle completely inside the triangle. The center of the circle is the incenter of the triangle. Okay, last one. Perpendicular bisectors. Perpendicular bisectors. Again, the name tells you what it is. Perpendicular, right angle, bisector, cuts it in half. So perpendicular bisector, right angle, bisector, cuts it in half. So that's what we're looking at here, kind of like the medians. Okay, there's a slight difference between perpendicular bisectors and medians. Medians would connect this midpoint to the vertex. Notice with the perpendicular bisector, it's not going to touch the vertex. It's perpendicular to that side. So that is still the midpoint right there. So these lengths are the same. We'll say 5 and 5. These lengths are the same. Let's go with 3 and 3. These lengths are the same. 4 and 4. Okay, but we're not connecting to the vertex. We are perpendicular to that side. The last center of the triangles that we're going to talk about is the circumcenter. Circumcenter. Now, with the triangle that we have, that circumcenter is outside of the triangle. So the orthocenter can be outside of the triangle. The circumcenter can be outside of the triangle. The circumcenter is equidistant. It's also equidistant from something. It's not equidistant from the sides, though. It is equidistant from the vertices. It is equidistant from the vertices. So if I draw a line from my circumcenter to each of my vertices, if it were a straight line, well, it's not very straight right there. Okay. Hopefully those look somewhat to be the same length. Let's say it's length 10. These are all length 10. Now, the perpendicular bisectors themselves are different lengths. Okay? That's not what we're measuring. We're measuring from the circumcenter to the vertices. Okay? So the last 3 words of our sentence are peanut butter cookies. Perpendicular bisector, circumcenter. So all of my children are bringing in peanut butter cookies. Altitudes, orthocenter, medians, centroid, angle bisectors, incenter, perpendicular bisector, circumcenter. If you can remember the sentence, you should be able to remember what creates them and what the center is. Now, I realize that there are 2 that start with C's. You got centroid and you have circumcenter. To be honest, the way that I keep them apart is the centroid is created by the median, the perpendicular bisectors create the circumcenter. Perpendicular is a longer word than median. Circumcenter is a longer word than centroid. Nothing mathematical about it. That's just how I keep them apart. The incenter and the circumcenter, the incenter is equidistant from the sides. The circumcenter is equidistant from the vertices. Same thing there. Okay? Incenter is shorter, sides is shorter. Circumcenter is longer, vertices is longer. That's really how I keep those straight in my head. Okay? Let me show you, we already saw an example here of the circumcenter being outside, but it can also be inside. It can be on it. There's an example of the circumcenter being on the triangle. It just depends on how your triangle is oriented. Notice on this one, there's a circle outside of the triangle. It is a circumscribed circle. Circumscribed means you go around the outside. So we've gone around the outside and all the vertices of the triangle are on that circle. It doesn't matter where I move it.